the algebraic function like polynomial, and this polynomial of degree 3 because the highest power is 3. Also the rational function, you have a numerator and denominator. The irrational function, I call it root function. So you have a root function as algebraic function as well. But what is the difference between algebraic and non-algebraic function? Algebraic function has addition, subtraction, division, multiplication, power, root, but the transcendental function, which is non-algebraic, doesn't have such addition or subtraction or multiplication. It is one piece like exponential function and logarithm function, as well as trigonometric function like sine x. Let's go for how we can find the vertical asymptote, horizontal asymptote, and oblique asymptote for the rational function. We have the vertical asymptote and horizontal asymptote. And if you don't have horizontal asymptote, you have oblique asymptote. So this function has a vertical asymptote. This is a vertical asymptote. I write it v dot a. And this one is the horizontal asymptote. So at the vertical asymptote, your function is not defined. Okay? But the horizontal asymptote, the function didn't touch this one horizontally. Okay? If you don't have horizontal asymptote, like this case, you have something called oblique asymptote. I write it O dot A. Now, we know how to find the vertical asymptote by putting the denominator of the rational function equal to 0 for any type of rational function. But the horizontal function, there is a condition for the function to have horizontal asymptotes. The degree of the numerator less than or equal the degree of the denominator. Like this case, the numerator is less than the degree of the denominator. In this case, the numerator and denominator have the same degree. Okay, but for this function, the degree of the numerator greater than the degree of the denominator, so you have no horizontal asymptote. So in this case, no horizontal asymptote. Okay. If you don't have horizontal asymptote, you will have oblique asymptote, right? Like this case. How to find the oblique asymptote? Asymptote by using the polynomial division. We will go through all of them. Let's go for this one. How to find the vertical asymptote? As we said, you put the denominator equal to 0. So, okay, but what is the denominator? X minus 1, put it 0. So, x equal to 1 is a oblique, is a horizontal asymptote. Sorry. It is a vertical asymptote. Vertical asymptote. For this one, take the denominator, put it equal to 0. Using the calculator, you can find the roots, or using the factorization, you can do it. 2x squared, you make it 2x and x. You have minus here, so you have 1 plus and 1 minus. 1 can be only factorized by 1, so you have no problem, okay? So equal to 0, when you have two things multiply together equal to 0, so this one equal to 0, so give you x equal to minus half. And this one equal to 0 give you x equal to 1. So you have two vertical asymptote, x equal to minus half and x equal to 1. Okay. Now, how to find the horizontal asymptote? If the degree less than, like this case, always put the horizontal asymptote y equal to 0, right? But when you have the same degree for the numerator and denominator, in this case, you put y equal to the coefficient. So this is the horizontal asymptotes for the case the degree of the numerator less than the degree in general. But when you have the same degree, you take the coefficient of the highest power in both numerator and denominator. So 1 over 1, so you 1 over. This is a horizontal asymptote. Okay. Here, in this case, y equal to the highest power coefficient over the highest power coefficient. So you have 3 over 2 is the horizontal asymptote. As we said, when you have the degree greater than the of the numerator greater than the degree of the denominator, you don't have no horizontal asymptote. But you have something called oblique asymptote. How to find the oblique asymptote? You have polynomial division and you have only caring about the result of the division, okay? You don't care about the remaining of the division, right? How to do this one? This is, we call it long division sometimes. So x cubed minus 4x divided by x squared minus 1. So you're dividing x cubed, the first one, by the first one. So you have x, you multiply x over here. So you have x cubed minus x. Okay? And you subtract. So you have cancel out this one. So you have minus 3x here. So can you divide anymore? No, I can't. So I don't care about what I'm going to do for the remaining. I'm caring about the result. So y equal to x is my oblique asymptote. Okay. Here is another extra practice to do it. Now let's go for the irrational function like root square x squared minus 4 cubic root of x. If you graph this one, you will find your domain start from 0 to infinity, okay? And your range also is from 0 to infinity. So this one has a domain 0 and infinity, and also the range from 0 to infinity. Okay. For this one, if you graph it, in this case, your domain coming from minus infinity and stop at minus 2, and union, the rest of this one, you start again from 2 up to infinity. This is a domain. What about the range? Yeah, the range is the same. You start from minus 2 to infinity. Okay. Sorry, I forget. Minus 2 is x. So you start from 0 for y because the range is the value of y. So you go from 0 to infinity. This is the range. Okay. The cubic root, yes, the domain from minus infinity because the value of x to positive infinity. This is the domain. For the range, yes, this one will be extended down and this one will be extended up. So the range will be from minus infinity to positive infinity. So x could be any real value, okay? But here, x should be greater than 2 minus 2 and less than 2, right? For here, x should be greater than or equal to 0, okay? And here also. The transcendental function is a function cannot be expressed, as we said, as a finite combination of algebraic operation, addition, subtraction, multiplication, division, okay? Like the exponential function, as you see the graph here, Yeah, the domain start from minus infinity to positive infinity. If you are talking about the domain, you are talking about the value of x. Okay, so the domain minus infinity to positive infinity. But about the range start from 0, but 0 is not included. So it's open. Up to what is increasing, go up to infinity. This is the range for the exponential function. The logarithm function, if you look at the graph here, you will find there is no value for negative x, right? So the logarithm, you cannot have x as a negative. So x always greater than 0, right? So the domain of the logarithm function is 0 open, because 0 cannot be included as well, to infinity. What about the range? The range is a value of y, so this is keep down. So the far down is minus infinity, and keep going up, and the far up is positive infinity. So this is the range for the logarithm function. For the sine, which is one of the geometric function, if you catch this one, you will find here, yes, the domain from minus infinity to positive infinity, but the range, the minimum value of y is -1 and the maximum value of y is y. So the domain of the sine is any value for, okay, but the range is the minimum of y, which is -1, and the maximum of y is 1, which is closed interval from -1 to 1. This is the range. Another property for the function could be even, odd, or neither even or odd. Okay. When it is even, when you plug in x and minus x instead of x, you will have the same function. And if you graph it, you will find the graph symmetric with respect to y-axis. But the odd function, when you plug in x by minus x, you have the same function multiplied by minus. Okay. If you graph it, you will find it symmetric with respect to the origin, as we will see here. For x squared with a quadratic function, this is a parabola, as we know before, right? It is upward because a, the coefficient of x squared, equal to 1, which is positive, so it's upward here. So it is symmetric with respect to y. It means if you have a mirror, you have this half exactly like this half. Okay. This is what does it mean symmetric with respect. Similar to this one, the cosine function exactly here, similar to here. So y axis is like a mirror. Okay. Do you remember the absolute value? Yes, I said it's a V shape, right? So if you look at y will appear like a mirror for any other half. Okay. Now, for the cubic function, if you graph it, you will find it is 180-degree rotation. For this one, you come to the other half. So it is symmetric with respect to the origin. This is the origin, we call it the origin. Okay. Sine, similar to this, is also symmetric with respect to the origin. Also, the identical function, y equal to x. Yeah, with the origin, you have the same half here. If you make 180-degree, you will have the other half identical. Now, you have practice to check whether the function is even, odd, or neither. You just plug in x by minus x algebraically. If you would like to graph it and check the symmetric, that's fine. Now we will go for another concept, which is a periodic function. What does it mean, periodic function? It means if you add a constant to x and you keep adding this constant, you will find your function repeated again and again and again, right? And this constant must be positive, right? And also non-zero, okay? Like the sine function, we know the graph of the sine function. The sine function has a period 2 pi. So from 0 to 2 pi, here, sorry, exactly this part has the same one for the minus 2 pi here, okay? So it is a copy. Every 2 pi, you have a copy, okay? So the function value repeat at a regular interval, which is 2 pi, okay? Now the cosine, if you graph the cosine, you will see also the period from 0 to 2 pi. You have a repetition for this graph every 2 pi. What about tan x? Tan x has a period pi only because you are repeated every pi, right? So the period here is 2 pi for the cosine and sine. The period for tan is pi. Yes, just to check, do you have asymptotes here? Yes. For the cosine and sine, you have horizontal asymptotes. How many asymptotes you have? You have 2. Yes, y equal to 1 and y equal to minus 1. So you have 2 horizontal asymptotes. Horizontal asymptotes. Okay, for the tan x, you have many vertical asymptotes. You have vertical asymptote at x equal to pi over 2, and also at x equal 3 pi over 2, and x equal to minus pi over 2, and x equal to minus 3 pi over 2. But you don't have horizontal asymptotes. Okay? So all of these one are the vertical asymptotes because the function is not defined at this place. Okay? Now, the exponential function is periodic or not? Let's check. How to check? You consider a constant t bigger than 0 and you plug in x by x plus t and you check you will have the same function or not. We know from the power rules e to the power x plus t, originally it is e to the x times e to the t, right? So these two are equal to the e to the x only when have e to the t is 1, and we know the exponential function equal to 1 when the exponent equal to 0. And we mentioned the period mustn't be 0. So e to the x is not a periodic function, is not periodic function. Okay, this is how to graph the exponential function. This is e to the x, which is very clear is not periodic. It has also horizontal asymptote. What is the horizontal asymptote for this one? It is the x-axis, which is y equal to 0 is the equation of the x-axis. This is the horizontal asymptote for the exponential function. Now, if you have f of x equal to sine 2x, how you can find the period of this function? We know the period of the sine is 2 pi, but 2x has a period equal to the period of the original function, sine x, divided by the amplitude here, 2. Okay? So the period of sine 2x will be pi. So when you increase the angle, the period will decrease, right? Now, for tan 3x, we know tan has period pi, okay? So you have to divide it by the amplitude, which is 3. So the period of tan 3x is pi over 3. If you have two functions, sine x and cosine x, but has a period 2 pi and this one has 2 pi as a period, so no problem when you're adding this two, you will have the same period, which is the same period as sine or cosine, which is 2 pi. Now, find the period of the function x times sine x. We know sine x has a period 2 pi, okay? But x is not a periodic function. So when you multiply a periodic function with non-periodic function, periodic function with non-periodic function, you will never have a periodic function, okay? Now we go for another concept. When the function increasing and decreasing, you just go for any 2 points, one bigger than the other, and you check the function at the bigger value bigger than the function at the lower value. Like this case, this is a function f of x equal to x plus 1. So if you come here from the left to right, you find your line is going up or it's increasing. So in this case, your function is increasing because from left to right, your graph is going up. Or take any two values, 0 and 2, for example. At 0, it is 1. As 2, it will be 3. So f of 0, less than f of 2, because when 0 less than 2 implies that. So this one is increasing. Okay. The decreasing function, when you have x1 less than x2, so f of x1 is bigger than f x2. Like this case, from left to right for the graph, you're going down, so it means it's decreasing. Or get at x equal to 0 and x equal to, let's take for this one, x equal to 2 or 3, it doesn't matter. So here you have 1, here you have 3. So 0 less than 2 and f of 0 is greater than f2. So your function is decreasing. So you can substitute algebraically to check is it increasing or decreasing. Now you have more practice to do. What we have done so far in this video, we talk about the rational function and we find the asymptotes for this one. Okay, the vertical asymptote, when we put the denominator equal to 0, and the horizontal asymptotes. In this case, we don't have horizontal asymptote because the degree of the numerator is higher than the degree of the numerator. But we have something called oblique asymptote. This oblique asymptote, we get it by the polynomial division. And we care about only the result of so the oblique in this case will be y equal to x. Okay? How to find the vertical asymptote, horizontal asymptote, and oblique, we know this one. And we know we have irrational function, and we have transcendental function, and we talk about the even function or odd function and periodic and non-periodic function, increasing, decreasing function,